Hello and welcome to helpyourmath.com. In this video, we're going to look at solving quadratic equations by completing the square. Before we get to that though, there are two things we have to review. The first thing is that there is one strategy that we can use for certain types of quadratic equations, and that is to take the square root of both sides. We're able to do that when we have an x squared term, but we don't have an x term. Or there might be an x term, but it's kind of hidden within. So in this example here, there actually would be an x term if we were to distribute the exponent to the two terms, but we're not going to do that. We're going to leave that like as it is. And in order for us to be able to take the square root of both sides, we do want to isolate the term that has the square. So the first thing we need to do is add 7 to both sides. And that would give us x plus 5 quantity squared is equal to 18. Then from here, we would take the square root of both sides. So we can do that because that square term is now by itself. It's now isolated. When we take the square root of the constant side, we need to add a positive or negative symbol because there are two cases. Anytime we're dealing with squares, when we take the square root of them, we have to consider both the positive case and the negative case. On the left-hand side, the radical cancels with the square, leaving us with x plus 5 is equal to positive or negative the square root of 18. The next thing before we isolate x that we want to think about is, can we simplify the square root of 18? So does 18 have any perfect square factors besides 1? And the answer is yes. We could think of 18 as 9 times 2 because 9 is a perfect square. That would give us, so this would become positive or negative, don't write the radical, the square root of 9 is 3 radical 2. Then we would subtract 5 from both sides, giving us our final answer of negative 5 plus or minus this 3 times the square root of 2. Now this indicates to us that there are two solutions, and it's helpful to separate our two solutions. So our two solutions for x are negative 5 minus 3 radical 2, and the other solution is negative 5 plus 3 radical 2. So we look at the two cases that that plus or minus sign give us. Okay, that's review part 1. Review part 2, the other thing we need is we need to be familiar with perfect square trinomials. So perfect square trinomials come in two forms: x squared plus 2xy plus y squared, x squared minus 2xy plus y squared. And the top one can factor into, this would be the root of the first plus the root of the third quantity squared. And this guy here factors into root of the first minus root of the third quantity squared. So we want to know how to recognize perfect square trinomials, but more importantly with completing the square is exactly what it sounds like. We have to complete the square. We are creating the perfect square trinomial. So we're going to have this here, x squared plus 2xy or x squared minus 2xy, and we're going to have to figure out what the third part is. Ready? Okay, let's go. For solving by completing the square, we're going to put those two concepts together, and we generally only use completing the square as a resort if a quadratic equation is unfactorable. If it's factorable, factor it. I know factoring might not be our favorite thing, but actually it turns out that of all of the methods for solving quadratic equations, that is the nicest one. So if it's factorable, factor it. Otherwise, you can complete the square or you can use the quadratic formula. When we complete the square, as I said, that's exactly what we're doing. We create a perfect square trinomial ourselves. Here are my suggested steps for completing the square or solving a quadratic by completing the square. So we're given the equation ax squared plus bx plus c is equal to 0. Step 1, isolate the constant. Usually you put the constant on the right-hand side. So what we're going to do with our given equation is we're going to subtract c from both sides. Next, we're going to divide all of the terms by the coefficient of x squared. So we're dividing, if x squared has a coefficient, we're going to divide it out to all the terms. That's going to leave us with x squared plus b over a times x equals negative c over a. Then we're going to determine the constant so that the left-hand side is a perfect square trinomial. So remember I said we're going to have two parts to it. We have to figure out what the third part is. How can we figure out what the missing piece is? Well, remember what we're talking about here. So it's x squared plus 2, I'm going to say yx just because I want to put the x's together, plus y squared. So we know the 2y. We're going to take that piece of information to create y squared. So because this is 2y, what that means to figure out the root y itself is we need to divide it by 2. And then to figure out the third piece, we need to square it. So we're going to take that middle coefficient and divide it by 2. Then we're going to square it. So what that would be is that would be b over 2a. And then when we square it, that's going to give us b squared over 4a squared. So this is that's going to be the third piece of our trinomial, our perfect square trinomial. We need to add that to both sides of the equation. Note that whether b over a is positive or negative, when you square it, it will always, 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 always be positive. So we're always going to be adding this term to both sides. Then we're going to factor the left-hand side, and what it's going to factor into is x plus b over 2a. So remember, we figured out what the root was when we divided by 2, and then that's going to be squared equals negative c over a plus b squared over 4a squared. From here, we can now solve by taking the square root of both sides. Keep in mind, when we take the square root of this side, we put that positive or negative in front of it. This looks really complicated, but when we actually see it with numbers, it's not so bad, but it can get bad. So it looks like it might be bad, and it starts out pretty nice. Let's look at some examples. I don't want to scare you yet. Okay, in our first example, we're going to solve the equation by completing the square. I always like to just double check that it can't be factored, and this one can't, so too bad. All right, so remember, first thing, we need to add 2 to both sides. Even when I add 2, I'm going to leave a space here on the left-hand side because I know that I'm about to do something. I'm about to add something here, so I'm going to leave a little blank there. Plus equals 2. Okay, so now x squared plus 4x is 2/3 of a perfect square trinomial. We're going to figure out the third, so we're missing the constant, right? We have the x squared term, we have the x term, we need the constant. Remember, what we do is we take the middle term and we divide it by 2, so 4 divided by 2, and then we're going to square it. 4 divided by 2 is 2, 2 squared is 4. So that means that if I add 4 here, that's going to be a perfect square trinomial. But I can't just willy-nilly add 4 to the left-hand side. I also have to do the same thing to the right-hand side. So I add 4 to both sides, which the addition property of equality tells me is okay to do. And now I have x squared plus 4x plus 4, which is a perfect square trinomial. So now we're going to factor that. What does it factor into? Remember what it was? It was root of the first term plus root of the third term. And we know the root of the third term because that was this right here. So we're going to square that. And then on the right-hand side, we're going to add 2 plus 4 is 6. Now we're ready. We have our square in place. So we can now take the square root of both sides. Keeping in mind with that constant, we need to add the positive or negative in front of it. The square root and the square cancel, giving us x plus 2 is equal to positive or negative the square root of 6. 6 is not it doesn't have any perfect square factors besides 1, so we'll just say root 6. And last step, subtract 2 from both sides to isolate our variable, giving us x equals negative 2 plus or minus the square root of 6. So how many solutions do we have? We have 2 solutions. One solution is negative 2 minus the square root of 6, and the other solution is negative 2 plus the square root of 6. So we see our 2 solutions here in our first example. Let's try it again. And if you feel ready, pause the video, try to see if you can complete the square on your own, and check back with me. Okay, first, did you check to see, was it factorable? No, it wasn't. All right, so first thing we're going to do is we're going to add 6 to both sides. This is going to give us x squared minus 10x. We're going to leave a blank spot there, equals 6. Okay, so now x squared minus 10x, that's 2/3 of a perfect square trinomial. What's the third? Take this middle piece, negative 10, divide it by 2, and square that. So negative 10 divided by 2 is negative 5, and negative 5 squared is 25. Remember, this is going to be positive 25. So we add 25 to both sides, because what that does is that forces this to become a perfect square trinomial. What does x squared minus 10x plus 25 factor into? Well, it factors into the square of the root of the first term minus the root of the third term squared. And we're always going to know that second piece of the when we factor it, because that's what it was when we divided the middle by 2. So we get x minus 5 quantity squared is equal to 31. Now we're ready to take the square root of both sides, and that leaves us with x minus 5 is equal to positive or negative root 31. 31 is a prime number, so I know it doesn't have any perfect square factors outside of 1. Next, we'll add 5 to both sides, and we end up with x equals 5 plus or minus the square root of 31. How many solutions do we have? We have 2 solutions. Our 2 solutions, one is 5 minus the square root of 31, and the other is 5 plus the square root of 31. So those would be our 2 solutions here for this example. Okay, those were the two nice ones. Now we're going to look at some where we kind of have a little bit more fractions to deal with. So that's going to be our final two examples. Okay, so this one, solve the equation by completing the square. Step 1, we need to move the constant to the other side, so we're going to add 10 to both sides. This is going to give us 3x squared minus 9x is equal to 10. You'll notice I didn't leave a gap right away because so far we haven't had to look at x squared having a coefficient besides 1, but now we actually do have a coefficient besides 1, so before we can think about completing the square, we have to think about the fact that we need to get rid of that 3. And we're not going to get rid of it. We're going to use the multiplication property of equality to divide all terms by 3. We're allowed to do that because of the multiplication property of equality. That gives us x squared minus 3x, now I can leave a gap, equals 10/3. Okay, so now we're ready to complete the square. We have 2/3 of a perfect square trinomial, x squared minus 3x. What's the third third? We're going to take this middle piece, -3, we're going to divide it in half, and then we're going to square it. When we square -3 over 2, we're going to end up with 9 over 4. So that's what we need to add to both sides. We need to add 9 over 4 to both sides. And what's that going to give us? The left side is now factorable. It's going to factor into x minus 3 over 2, quantity squared. So remember, this tells us what that root is going to be, that second root. Or you can do 9 over 4, the square root of that, which will still be 3 over 2, but you need to put the minus because the middle term is a minus. On the right-hand side, we do have some fractions to deal with. So what have we got here? Common denominator will be 12, so I'm going to multiply by 4 over 4. Here I'm going to multiply by 3 over 3. That's going to give me 40 plus 27. So I'm going to have 67 over 12. Cute. Now we want to take the square root of both sides, put my positive or negative, square root of 12. Okay, on the left-hand side, we have x minus 3 over 2 because the square and the square root cancel. On the right-hand side, I've got a mess over here. So first thing I'm going to do is I'm going to separate the radicals. So I'm going to have radical 67 over radical 12. Now we want to rationalize the denominator, but before I do that, let's see if we can simplify the square root of 12 because that will save us a little bit of work. Yeah, we can simplify because 12 has a perfect square factor of 4. So this would become positive or negative root 67 over 2 radical 3. So now to rationalize the denominator, I just need to multiply by the square root of 3 over the square root of 3. I'm running out of space here. That's okay. We have x minus 3 over 2 is equal to positive or negative, and then we have 67 times 3, that's going to be 1201, over, this will be 2 times root 3 times root 3, this just makes 1 3, so we're going to have 6. Okay, few more steps here. This one's a little, as I said, these can get complicated and they get fraction heavy. Now we need to add 3 over 2 to both sides. When I go to add 3 over 2, you can leave them separate, or if you want to combine them, you can. I would say the fewer steps, the better. So we're going to write our final answers. The first answer is 3 over 2 minus the square root of 201 over 6. And the other answer would be 3 over 2 plus the square root of 201 over 6. And those would be our final answers here. Okay, one more example where, as if this wasn't complicated enough, we're going to take it a step further. Hold on tight. Okay, first thing, we need to add 9 to both sides. This gives us 2x squared plus 5x is equal to 9. Next, we need to divide by the coefficient of x squared, so every term is getting divided by 2. This will give me x squared plus 5 over 2x, I'm going to leave a space there, equals 9 over 2. Now, I have 2/3 of a perfect square trinomial, x squared plus 5 over 2x. I need to figure out the third third. So remember what we do, we take the middle coefficient and we divide it in half. Dividing it by 2, we'll put another 2, a factor of 2 in the denominator, so we're going to have to put 5 over 4. And then we need to square that, so that's going to give us 25 over 16. Then on the right-hand side, I need to add 25 over 16. Okay, so now we can factor the left-hand side. We're going to have x plus 5 over 4. Quantity squared is equal to, I need common denominators. It's not going to be 4, it's going to be 8 times 8. So that's going to be 72 plus 25 over 16. That will be 97 over 16. The good news is actually this one, while it's complicated now, the good news is that the denominator is a perfect square. Okay, so now we're ready to take the square root of both sides. And we get x plus 5 over 4 is equal to positive or negative. I'm going to split up my radicals, 97 over root 16. And this ends up becoming root 97 plus or minus over 4 because 16 is a perfect square. Hooray! Oh, this isn't so bad, is it? See, I had you all worried for nothing. Then last step, we're going to subtract 5/4 from both sides. Because they have the same denominator, I'm just going to combine the numerators because that's what we would do if, when they have the same denominator. I didn't do that in the last example because they didn't have the same denominator. I could have. I chose not to. But here we can say x is equal to negative 5 plus or minus the square root of 97 over 4. So how many solutions does this one have? Just like the other three, it has 2 solutions. What are my 2 solutions? Well, one is negative 5 minus the square root of 97 over 4. And one is negative 5 plus the square root of 97 over 4. These have been examples of completing the square. Thank you for stopping by.